Good day, everyone. My name is Kailaashan, son of Suthagar, metric number MA22126, and today I'll be presenting on Six Sigma DMAIC, which stands for Define, Measure, Analyze, Improve, and also Control. This methodology is widely used in engineering and industry to improve quality, reduce defects, and enhance process efficiency in a systematic manner. This presentation is prepared under the guidance of Professor Madhya T.S. Dr. Muhammad Haji Matnoor from the Faculty of Mechanical and Automotive Engineering Technology, UMPSA. The content focuses on understanding Six Sigma concepts clearly and applying them in real engineering and industrial contexts. DMIC is the core improvement framework within Six Sigma. It provides a structured step-by-step approach to identify problems, analyzing their causes, implementing solutions, and maintaining improvements. Moving on is the history of Six Sigma. Six Sigma is originated in the mid 1980s at Motorola. At that time, Motorola faced serious challenges such as high defect rates, product failures, and strong competition from global manufacturers. Engineer Bill Smith introduced Six Sigma to reduce variation and also improve reliability. And also in the 1990s, Six Sigma gained worldwide recognition when General Electric, led by Jack Welch, adopted it across the entire organization. GE applied Six Sigma not only in manufacturing but also in finance services and management processes. Moving on is the Six Sigma introduction. Six Sigma is a data-driven quality improvement methodology. It focuses on identifying defects, errors, and variation processes. By reducing variation, Six Sigma also improves customer satisfaction and operational efficiency. These Six Sigma characteristics are: the goal of Six Sigma is to achieve 3.4 defects per million opportunities. This extremely low defect rate represents near perfect quality. Moving on is Six Sigma DMAIC. DMAIC is specifically used to improve existing processes that are not meeting performance expectations. It is especially used when defects are present but the root cause is not clearly understood. Moving on is Six Sigma DMADV, which is also known as Define, Measure, Analyze, and also Design and Verify. This DMADV is DMADV is the objective to ensure that customer requirements are met from design stage, preventing future and quality problems. The difference of DMAIC versus DMADV is, in simple terms, DMAIC improves while DMADV designs. Selecting the correct methodology ensures that resources are used effectively and project objectives are achieved efficiently. Moving on is the define phase, which is the first phase. The define phase is the foundation of the DMAIC process. In this phase, the problem is clearly identified and project objectives are defined. A strong define phase prevents confusion and ensures the project remains focused. Moving on is the define phase key activities. These include voice of customer, critical to quality, CPOC, and project charter. Together, these tools help define the project scope and direction. Firstly is voice of customers. VOC is used to capture customer expectation, complaints, and requirements. This ensures the improvements are aligned with that customers actually value, not internal assumptions. Next is critical quality. CTQ characteristics translate customer needs into measurable performance requirements. These metrics become the main focus during improvement and evaluation. Thirdly is CPOC. CPOC provides a high-level overview of the process. It helps teams understand suppliers' inputs, process steps, outputs, and customers, ensuring a shared understanding of the process. Next is project charter. The project charter formally documents the problem statement, objectives, scope, timeline, and also team roles. It serves as a reference point throughout the DMAIC project to avoid scope creep. Moving on to the next phase, which is the measure phase. The measure phase focuses on collecting reliable data about current process performance. This data establishes a baseline that will be used to compare future improvements. During this phase, defects, variation, and performance gaps are identified. Accurate measurement is critical as incorrect data leads to incorrect conclusions. Firstly is House of Quality, which is also known as HOQ. HOQ converts customer requirements into technical specification. It helps prioritize improvement efforts based on customer importance and technical feasibility. Next is benchmarking analysis. Benchmarking compares current process performance with industry standards or best practices. Next is also process capability. Process capability analyzes, evaluates how well a process meets customer specification. CP and CPK values indicate process stability and consistency. Moving on to the third phase, which is analyze. The analyze phase focuses on identifying the root causes of defects and variations. The tools which are used in this phase are DOE, which is also known as design of experiments, failure mode and effect analysis, which is also known as FMEA, concept selection matrix, and also simulations. Firstly is DOE. DOE allows multiple variables to be tested simultaneously, which also helps identify which factors have the greatest impact on process performance. Next is FMEA. FMEA identifies potential failure modes and evaluates their risk. Moving on is the concept selection matrix. This tool evaluates possible solutions using weight criteria. Last but not least is simulation. Simulation models predict process behavior without affecting real operations. Moving on to the improve phase. The improve phase focuses on implementing solutions that eliminate root causes. Solutions are often tested on small scale before the full deployment. The methods which are used are SOPs, Pokayok, and also Kaizen. Starting with standard operating procedure, which is also known as SOP. SOPs provide clear instructions for performing tasks. Moving on is error proofing Pokayok. Pokayok prevents mistakes before they occur. Next is continuous improvement, which is also known as Kaizen, which focuses on continuous small improvements involving employees at all levels. Moving on to the last phase, which is the control phase. The control phase ensures that improvements are sustained over time. It prevents the process from reverting to previous poor performances. The first tool which is used in the control phase is checklist. Checklists standardize tasks and reduce human error, which help maintain consistent quality. Next is the control chart. Control charts monitor process performance over time, which also help detect variation before defects occur. Next is educate personnel and roles. Employees are trained on new procedures and responsibility, which clear role allocation ensures accountability and long-term success. In conclusion, Six Sigma DMAIC provides quality and efficiency by minimizing defects and process variability. DMAIC also offers a systematic framework for identifying, analyzing, and resolving process issues. Lastly, sustainable enhancements are attained via measurement, root cause analysis, and process regulation. These are the references used during this slide making. And thank you. That is all from me now.